We want to determine the equation for the graph in blue based upon what we know about the graph of y equals x squared provided here in red. So let's let y equals x squared be f of x. This will be f of x equals x squared. And we'll let the blue graph be g of x. Because g of x is a transformation of f of x, we can write g of x in terms of f of x in this form here, where the values of a, b, c, and d transform f of x. So the first step is to recognize what type of transformation has occurred to form the blue graph. Probably the first thing we should notice is this graph opens up and this graph opens down, which means the graph of f of x must have been reflected across the x-axis. So let's record that. Next, we need to determine if there's a vertical stretch or compression or a horizontal stretch or compression. Well, notice the shape of the red parabola and the blue parabola are the same, which means there has not been a vertical stretch or compression or horizontal stretch or compression. So this does give us enough information to determine the value of a. If the graph is reflected across the x-axis, that means a must equal -1. That should make sense because by changing the sign of the function values for f, we're changing the sign of the y values, which would reflect the graph across the x-axis. In addition to the reflection, notice how the vertex has changed as well. The vertex here is at the origin, but the vertex of the blue parabola is at the point -1, -3, which means the graph has also been shifted left 1 unit and down 3 units. So again, left 1 unit and down 3 units. Well, knowing the graph has been shifted left 1 unit gives us enough information to determine the value of c, and knowing it's been shifted down 3 units gives us enough information to determine the value of d. So we can write g of x in terms of f of x as g of x equals a times f of x plus c plus d. Now we'll determine the values of a, c, and d, and then we can determine our equation for g of x. Again, we already determined a was equal to -1 because of the reflection across the x-axis and no vertical stretch or compression. C determines whether the graph is shifted left or right. If C is positive, the graph is shifted left, and if C is negative, the graph is shifted right. Since our shift is left 1 unit, that means C is going to be +1. Remember, C tends to be the opposite sign that we would think. It's shifted left in the negative direction, but C is +1. The sign of D tends to be more intuitive. If D is positive, the graph is shifted up. If D is negative, the graph is shifted down. So in this case, because we have a shift of down 3 units, D is equal to -3. So we can write g of x in terms of f of x as g of x equals -1, or just negative, f of the quantity x plus 1 minus 3. But remember, f of x is equal to x squared, so we can write g of x as g of x equals negative the quantity x plus 1 squared minus 3. This would be the equation of our transformed blue function. I hope you found this helpful.